Hello everyone. On this video we will look at building linear models from data. Okay. So far we probably know how to plot points on a graph. Okay, so let's say we have y equals 2x plus 1. If we plug in a -1, we get -1. So if we plot that point, -1, -1, it's about there. Okay. We plug in x equals 0, we get 1, which is about right there. And if we plug in x equals 1, 2 times 1 is 2, plus 1 is 3. It's about right there. Okay. So which means you just get your straight edge, and all of the points are linear because your equation is linear. So it looks about like that through all 3 points. Okay. So that's the graph of y equals 2x plus 1. Okay. So we know that for this particular graph, or this particular function, for y equals 2x plus 1, you have -1, -1. When x equals -1, y equals -1. When x equals 0, y equals 1. When x equals 1, y equals 3. And you can keep on going. You can say when x is equal to 2, y is equal to 5, and you can go on forever in both directions. Okay. Now, let's say if you plot just the points, without connecting them. Okay, so just like we did up here, but if we have all of our points, our -1, -1, our 0, 1, and 1, 3. Okay. Now, if you have just the ordered pair points plotted here, then what you have is called a scatter plot. Okay. Then your graph is a scatter plot. Okay. And it's really just a series of points on a graph. All right. Okay. So if you are still writing this, feel free to press pause. But we're going to go ahead and move on to the next page. Okay. So let's say you have a lot of ordered pair points. Okay, you just have tons of data points everywhere. Okay, they're not linear, but they have the same pattern. See, this pattern is increasing. Even though it's a bunch of points all over the place, it's going in an increasing manner. Okay, so this is a set of linear relations where the slope is positive. Okay, now here we have all these data points that we plotted on the graph, but they're headed in a declining or decreasing slope. Okay, this is a set of linear relations where your slope is less than 0. Okay, now if you look here, these points here, you got all these data points and you plot them, and they're not going in a linear fashion like these two. You're plotting them and they're kind of swerving up, or they're swerving out and going back up. These are nonlinear relations because their pattern is not linear. Okay. So when you have all these data points, and you can kind of give an estimate as the direction that the points are going, that's what you do with linear regression. Okay, so if you have a linear scatter plot, you can find the linear equation that closely describes the pattern. Okay, so if you look here, you see this kind of describes the pattern. This line kind of describes the pattern of all these data points. Okay, now that line is called the line of best fit or the regression line. Okay, and that's what we're going to basically make here. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and do a quick example. Okay, so let's say for this particular table, we want to A, draw a scatter plot, B, select 2 points from the scatter plot, and find an equation for the line for those 2 points. Okay. C, we want to graph a line from the 2 points on part B. And let's say for D, we want to use our calculator to find the line of best fit. Okay. So let's say we start with A. All right. So we want to draw our scatter plot. Okay, so let's get our graph. So you have your X and you have your Y. Okay, so let's say it's 3, 6, 9, 12, 3, 6, 9, and 12. It's a nice scale. Okay, so we know that the first point is 3, 0. X is 3, Y is 0, so we go there. Our next point is when X is 5, Y is 2. So 5 is about here and 2 is about there. Okay, and when X is 7, Y is 3. There's 7 is about here and 3 is here. Okay. When X is 9, Y is 6, so we go from 9 and go up to 6. When X is 11, Y is 9, so we go up from 11 to about 9. That's close enough. Maybe a little lower. And when X is 13, Y is 10, so this is 13 about here. And 10 is about right there. Okay. So as you can see here, it's not linear. It's giving a kind of a linear pattern. You can see it's increasing, but it's not completely linear. Okay. So for B, we're going to select 2 points from the scatter plot and find an equation. Okay, so I'll do B over here. Okay, and the 2 points I'll pick is 5, 2, and 11, 9. Okay, so just 5, 2, and 11, 9. Okay, so first we need our slope. It's y2 minus y1 over x2 minus x1. Okay, so that's 9 minus 2 over 11 minus 5. So our slope is 7/6. Okay, so we use our point slope form. Okay, so y minus, I'll use 11, 9 for my x1, y1. Okay, so y minus 9 equals 7/6 times x minus 11. Okay, so if we distribute that 7 over 6, we have y minus 9 equals 7 over 6x minus 77 over 6. So if we add 9 to both sides, that cancels out, and you have y equals 7 over 6x minus 9 is 54 over 6. So negative 77 plus 54 is negative 23 over 6. Okay, so that's the line between those 2 points. Okay, so for C, they want us to graph the line from part B. So I'm just going to go ahead and do C right with this one. Okay, so this is 5, 2, and this is 11, 9. So we're going to go ahead and just draw a straight line right through it. Okay, so let's draw a straight line right through those 2 points. Okay, let me kind of fill that in a little. Uh-oh. There we go. That's good enough. Okay, so now we want to use our calculator to find the line of best fit. So basically, it's going to be the equation of the line similar to this, but it's going to be the line that really points out the pattern of the whole scatter plot. Okay, so let's get my calculator here. Okay, so I'm going to go ahead and put my calculator right there. Try to get it out of the light. All right, so first thing we're going to do is we're going to hit the apps button. Bring those up, and then we're going to go to data matrix. Data matrix. Hit enter. Then we're going to go ahead and go to a new one. Okay, so the type, hit the right arrow and go to list. Hit enter. Go down, and the main, I'll go into contacts. And variable, I'm going to use D, so let's say alpha. Let me make sure I get that. D, there we go. And hit enter. Okay, now C1 is all of our X values. Okay, so all the X values, let me put the list down here, we're going to put into our C1. Okay, so you have 3, 5, 7, 9, enter, 11, enter, 13, enter. There we go. Now our C2 is going to be our Y values. Excuse me. Okay, so 0, 2, 3, 6, 9, and 10. 0, 2, 3, 6, 9, and 10. Okay, so now we have all our values in. We're going to go through F5 and calculation type. We're going to hit the right arrow, and we're going to go to linear regression. Okay, and hit enter. Okay, now for our X, that's all the ones in our C1 list. Okay, so we're going to hit alpha and C, and 1. Then we're going to go down, and all the values in our Y is the list in our C2. So we're going to hit alpha, hit C, and 2, there we go. Okay, so we have our C1 and C2. Okay, we go ahead and hit enter. And that is our equation for our linear regression, or our line of best fit. Okay, so let me move this up a little bit. Let me see. All right, let me move the camera a little closer to it. Maybe that'll help. Okay, so you can see here where it says y equals ax plus b, your a is 1.057143. Okay, so that's your slope. Your b is negative 3.457143, so that's your y-intercept. Okay, so we have everything we need here to have our equation. So let me move the camera back up and move this up here. So for D, the line of best fit is y equals 1.057143x minus 3.457143. Okay, so that's the equation that best fits these scatter plots, even though they're not linear. It's kind of somewhere in the middle. All right, so let me see, and just in case you kind of didn't follow all the steps for TI-89, these are all the steps here, so you can pause it and write it down. You have apps, then data matrix, then new, then hit list, then variable, then enter, then all the x values and y values. Okay, then F5, calculate type, linear regression, enter. All your alpha C1 and C2, then enter again. So these are all the steps for TI-89. Okay, so hopefully this all made sense, and I'll see you on the next video.